Welcome to Colorado Engineers 2012. I'm Eric Young, President of the American Council of Engineering Companies of Colorado, and your host for this program that takes a look at the projects that were designed and completed by Colorado engineers in 2011. The projects you're about to see were recognized by the Engineering Council for their societal contributions, engineering innovations, and sustainable solutions, and that use the technical expertise and practices that engineers employ every day to ensure the ongoing health, welfare, and safety of communities. It's an interesting look into what it takes to create the important infrastructure that is a part of our everyday life. Joining me is professional engineer Peter Binney, who has managed the development of the assessment and rating system for the newly formed Institute for the Sustainable Infrastructure, commonly referred to as ISI, where he advises owners and project teams on how to improve the sustainable performance of transportation, water, and other infrastructure projects. Throughout our program, he will examine the sustainable aspects Colorado engineers applied to these projects as they relate to our citizens from an environmental, social, and economic perspective. Our program features infrastructure projects in Georgetown, Trinidad, Teller County, Pueblo, Colorado Springs, Delta, Colorado, and a major Washington State river restoration design that was inspired by the North Table Mountain water treatment plant near Golden, Colorado. We also take a look at the engineering behind the extraordinary fossil find near Snowmass Village, Colorado, where engineers were expanding the Ziegler Reservoir in Pitkin County. It's a fascinating story about engineers whose lives were forever changed while working on a Colorado water project that uncovered the largest mammoth and mastodon fossil bed in history.
To meet requirements of a new permit for discharging wastewater effluent into the Gunnison River, the city of Delta, Colorado faced several treatment plant upgrades and costly improvements. In addition to the discharge permit, the presence of threatened and endangered fish species compelled the use of a diffuser to meet river water quality requirements. Engineers from URS Corporation designed and launched Delta's new wastewater effluent river diffuser with enhanced dispersion to meet Gunnison River water quality standards. The new diffuser eliminates the need for additional expensive treatment processes. This unique project was completed 2.5 years before deadline and was an impressive $364,000 under budget. The innovative processes utilized for the project and its significant time and budget savings has inspired others to consider similar approaches to pending infrastructure improvements.
Personal gratification for me on the project was we've got a city of Delta who is limited economically. To put in treatment processes to reduce ammonia and some of the other things of concern in the treatment process would have cost about $1.4 million. Instead, the effluent river diffuser we put in only cost about $400,000. For the Delta effluent river diffuser, we used Tideflex duckbill type diffusers to distribute the effluent across the river to meet the water quality standards for the Gunnison River. Use of that technology, use of HDPE pipe as a durable pipe material for an in-river application, subject to the rigors of being in a river channel, were, I believe, the most innovative and type part of this project. For the Delta effluent river diffuser, the major benefit to the public, in addition to achieving water quality standards driven by threatened and endangered species in the Gunnison River, they don't see this diffuser. It has no effect on the recreational use of the river at that wastewater treatment plant. It's completely submerged, you can pass over it, not even know it's there.
The City of Delta wastewater system discharges to the Gunnison River that is in an ecosystem that supports a number of threatened and endangered fish species. Stringent water quality standards could have required expensive upgrades and improvements to renew the city's operating permit. The project team from URS successfully applied a number of sustainability principles while they achieved the city's primary objective which was to obtain a new wastewater discharge permit. An innovative use of a diffuser system protects the environment and the ecosystem for the threatened and endangered fish species. By delivering a solution ahead of budget and schedule, the community benefited from a cost-effective solution that can reduce the impact on ratepayers of higher utility bills. These are both social and economic benefits that were provided by the design team.
The most difficult portion of the extensive Woodman Road Corridor Improvement Project was the Woodman Road and Academy Boulevard intersection in Colorado Springs, Colorado. The need to improve this at-grade intersection was critical, as more than 100,000 cars a day passed through this vibrant commercial and residential center. 2 past improvement initiatives had failed to pass, which meant that in order to have this vital improvement initiative implemented, achieving stakeholder buy-in would require not only a design that would fit into a small interchange footprint, but also a commitment to public involvement. URS Corporation engineers determined that a 300-foot wide, inverted single-point urban interchange with skewed ramp configurations would be the best option to fit the small footprint, improve traffic flow, and minimize disruption to the highly developed area. Stakeholders used a model home approach to select aesthetic treatment options to express the community's style. By being sensitive to community needs, the URS team developed a true partnership with the city and trust from the community. URS provided a solution to the puzzle that the city had been struggling with for more than 25 years.
I think the most impressive innovation to the Woodman Road project was probably the best fit approach we took to making an interchange fit into a very tight urban area. That included both raising Woodman Road and lowering Academy Boulevard, which kind of impacted a lot of utilities and made it very difficult to phase the construction. As far as the engineering side of things, the geometrics on the project were very, very difficult just because of the tight urban, there's Home Depot and Sam's Club and King Soopers and every other big box store you can imagine packed around the intersection. And to be able to limit the impacts to these big businesses and the residential areas that were right around there it was very difficult. I mean, it took, we had to raise Woodman Road and lower it, and to figure out the drainage that went along with it and the utility impacts, and the 42-inch water line that serves a third of the city of Colorado Springs with water. To figure out how to get that thing relocated within the 5-day window that we were given by Colorado Springs Utilities, it was pretty gratifying to see it all come together like we had planned it. In terms of process technology, I think what made Woodman Road special was really the collaboration with the public to make it a project that we could all be proud of. The collaboration with the public and the stakeholders was to make it a model home project was really big. The collaboration with CDOT, Federal Highway Administration, to get stimulus funding. It was the biggest stimulus funded project in the state, and there was a lot of collaboration to get the project out to bid and to meet the stimulus requirements. And then I think collaboration through construction with the contractor, Edward Kramer & Sons, to get the project in ahead of schedule and on budget. And on the complex nature of the project, it was really special.
For more than 25 years, the local community had opposed various proposals to improve this important interchange. With continued growth, over 100,000 vehicles each day have impacted the community, and traffic congestion would have to be relieved with an expanded and efficient reconstruction of the interchange. The project team from URS invested in a major public relations effort with the city to work with the community to identify and include project features that reflected their values and desires. By identifying community concerns, working with neighborhoods, and adapting the design to reflect those values, support to upgrade the interchange and relieve that traffic congestion was received. This is a strong social benefit and illustrates the value of transparent and responsive communication with the community. A commitment to identifying aesthetic features that were identified by the local citizens guided designers to reflect elements in the constructed project and to minimize the project footprint. This increased the opportunity for their support of the new interchange and reflected a partnership approach to resolving a significant traffic congestion problem for citizens and for the community. A sustainable transportation solution was provided to the community as an amenity and asset after decades of frustration. The project approach demonstrated a high commitment to the social value of the community and not just to the congestion at the road interchange. Environmental sensitivity was also demonstrated in the design approaches.